Hey there guys, in the last video we looked at adding, subtracting, and multiplying monomials, and in this video we're going to go to dividing monomials. So when we were multiplying monomials we had what was called the product rule, which said that if we had two powers with the same base multiplied together, we kept the base and we combined or added together our exponents. Well, when we're dividing monomials we have what's called the quotient rule. And this just says the opposite. If we have a power divided by another power and they both have the same base, we keep the base and we subtract. We take the top exponent and we subtract the bottom exponent. So that is what we're going to practice on this page here. We have several quotients that we're going to find, and we're going to use this exponent quotient rule to simplify these expressions. So number one, we have 12 to the 7th power divided by 12 to the 5th power. So to simplify this, we're going to keep our base, which is 12, and we're going to take our top exponent, which is 7, and we're going to subtract the bottom exponent, which is 5. So we get 12 to the 7 minus 5 power, which is 12 squared. Number two, we have 9 to the 3rd power divided by 9 to the 5th power. So we'll keep our base, which is 9, and we're going to take the top exponent, 3, subtract the bottom exponent, 5. 3 minus 5 gives us a negative exponent, so we get 9 to the negative 2 power. And remember, all negative exponents we want to rewrite as positive exponents. So this becomes 1 over 9 squared, which would be our answer. Number 3, negative 5 to the negative 1st divided by negative 5 squared. So our base we keep as negative 5. We take the top exponent, negative 1, subtract the bottom exponent, 2. So we have negative 1 minus 2. This gives us negative 5 to the negative 3rd power. Again, negative exponents we don't want in our final answers, so we can rewrite this as 1 over negative 5 to the positive 3rd power. Let's try this now with some variables. We have x to the 10th over x squared. So I keep the base, x, and we take the top exponent minus the bottom. So that would be 10 minus 2, and we get x to the 8th power. Next, number 5, w squared divided by w to the 7th. We keep our base and we take the top exponent 2, subtract the bottom exponent 7, and this gives us w to the negative 5th power. W to the negative 5th power we rewrite as 1 over w to the positive 5 power. Number 6, we have p over p to the 4th. So the base p we keep. Our top exponent is a 1, so this is 1 subtract 4. And this becomes p to the negative 3rd power. Again, negative exponents we rewrite using our negative exponent rule. So this is 1 over p to the positive 3rd power. Okay, let's try this now with multiple variables. So number 7, we have m to the 3rd n to the 6th over m squared n squared. So I'm going to start with my m's. M to the 3rd divided by m squared is going to give us m to the 3 minus 2 power. And then for my n's, we have n to the 6th over n squared. That's going to give us n to the 6 minus 2 power. So this becomes m to the 1st, or just m, times n to the 4th power. Number 8, again we'll start with our r's, so the like bases. So I have r squared divided by r to the negative 3rd power. So I'm going to be careful with my signs here. This is r to the 2nd minus negative 3. So this becomes r to the 2 plus 3 power. And then for our other variable, the s's, we have s to the negative 5th over s squared. So this will be s to the negative 5 minus 2 power. So we rewrite this as r to the 5th times s to the negative 7th power. We know we don't want negative exponents in our answer, so this is going to be a fraction answer, but think about what goes on the top, what goes on the bottom. R to the 5th is fine because that's a positive exponent. This is like r to the 5th over 1, so this can stay on the top of our fraction. S to the negative 7th is really 1 over s to the 7th, so the s to the 7th will go on the bottom of our fraction. So our answer is r to the 5th over s to the 7th. Okay, number 9, 3 variables this time, but we'll treat it the same way as we did the 2. So we'll start with the a's. We have a squared over a to the 9th. This is going to give us a to the 2 minus 9 power. We have b to the 9th over b to the 3rd. This is going to give us b to the 9 minus 3 power. And then we have c to the 4th over c to the 4th. This will give us c to the 4 minus 4 power. So we get a to the negative 7th, b to the 6th, and c to the 0. Okay, because of this negative exponent here, we're going to have a fraction answer because we'll need to flip this a to the negative 7th to become 1 over a to the positive 7. Our b to the 6th can stay as it is. This is b to the 6th over 1. And then c to the 0, remember anything to the 0 power is just 1. So we're multiplying 1 over a to the 7th times b to the 6th over 1 times 1. So this becomes b to the 6th on the top of our fraction. And then in the denominator we have our a to the 7th. Okay, now we're going to practice with some examples with coefficients. So number 10, we have 24c to the 10th divided by 8c cubed. So our coefficients are 24 and 8, and 24 divided by 8, we just simplify like normal. 24 divided by 8 is 3. Next, we do our variable powers. So we have c to the 10th divided by c cubed. This is going to be c to the 10 minus 3 power. And so we get c to the 7th power. So this becomes 3c to the 7th. Number 11, we have negative 36k to the 6th divided by 4k to the 4th. Our coefficients are negative 36 and 4. Negative 36 divided by 4 is just negative 9. And then for our variables, k to the 6th over k to the 4 would be k to the 6 minus 4, which becomes k squared. Number 20, we have 20 divided by negative 5. 20 divided by negative 5 is negative 4. And then we have a to the negative 12th divided by a to the negative 4th. So this would be written as a to the negative 12 minus negative 4. So again, we have a double sign here. This becomes plus 4. So this is a to the negative 8th power. Negative exponents need to be rewritten. So we can rewrite this as 1 over a to the positive 8 power. Negative 4 is just negative 4 over 1. Don't rewrite the negative 4. Okay, negative coefficients are fine. So our answer for this one is going to be the fraction negative 4 over a to the 8th. Okay, for 13, we have 15 over 24 for our coefficients. 15 over 24 is a proper fraction, which means this is going to stay a fraction, but we can reduce. 15 and 24 are both divisible by 3, so this becomes 3 over 8, the fraction 3/8. And then our variables, we have v to the 15th over v to the 5th. So this becomes v to the 15 minus 5, which is v to the 10th. So we have 3/8 times v to the 10th. V to the 10th can be rewritten as v to the 10th over 1. So I can make this one whole fraction by writing this as 3 v to the 10th all over 8. Okay, number 14, 8w to the 2nd over 20w to the 9th. My coefficients, again, are 8 and 20, so the fraction 8 over 20 will reduce to the fraction 2/5. And then we have w to the negative 2 over w to the 9th. So this is w to the negative 2 minus 9 power, which is w to the negative 11th power. W to the negative 11th we rewrite as 1 over w to the positive 11. And so our answer for this will be 2 over 5 w to the 11th. Number 15, 16 mn to the negative 2 over 10 m squared n to the negative 8. So we have 16 over 10, which reduces to 8 over 5. Next we have m over m squared. So this is m to the 1 minus 2 power, which is m to the negative 1st. Finally, we have n to the negative 2nd divided by n to the negative 8th. So this is n to the negative 2 minus negative 8. So double sign, n to the negative 2 plus 8, and that gives us n to the positive 6 power. Negative exponents we want to rewrite, and so we have 1 here. This becomes 1 over m to the 1st, or 1 over m. We can leave 8/5 alone, and we can leave n to the 6th alone. Okay, n to the 6th is just n to the 6 over 1. So we get a fraction answer, and it becomes 8 n to the 6th in our numerator and 5m in our denominator. Okay, finally here we have some mixed practice. So we're going to practice both the product rule and the quotient rule here in these examples. Number 16, we have 6n to the 3rd over 4n times 7n to the 9th. So I'm going to start this problem out by simplifying my denominator first. So our denominator, we can use the product rule. In the denominator, we have a 4 times 7. 4 times 7 is 28. And then we have an n times n to the 9th. N times n to the 9th is n to the 10th. Our numerator we'll just keep as 6n to the 3rd. So now that I've simplified the denominator by multiplying what's in the denominator, now I can do my quotient rule. So I can simplify this fraction 6 over 28. 6/28 will reduce to the fraction 3/14. And then n to the 3rd divided by n to the 10th will give us n to the 3 minus 10, which is n to the negative 7th. N to the negative 7th, a negative exponent, we want to write as 1 over n to the positive 7. So this becomes 3/14 times 1 over n to the positive 7. And our final answer becomes 3 over 14 n to the 7th. 17, we have 9 w to the negative 4th times 48w over 6w to the third. So because this is all multiplication, I can rewrite 9w to the negative fourth as 9w to the negative fourth over 1. And now let's multiply these fractions all together. Remember, when we're multiplying fractions, sometimes canceling can help. So what I can do here is I can cancel along this diagonal. I have a 6 and a 9 as these coefficients. 6 and 9 are both divisible by 3, so I can make this 6 a 2 and this 9 a 3 if I multiply, or if I divide both 6 and 9 by 3. So now I can multiply in my numerator 3 times 48. 3 times 48 gives me 144. And feel free to use a basic calculator if you need to for that. And then we have w to the negative fourth in the numerator times this w here. W to the negative fourth times w to the first is just going to be w to the negative fourth plus 1. In the denominator, we have a 1 times 2 w to the third. So now we'll simplify this fraction. We have 144 over 2. 144 divided by 2 becomes 72. And then for our variables, we have w to the negative 4 plus 1 power over w to the third. Well, w to the negative 4 plus 1 is negative 3. So we have negative 3 minus the 3 on the bottom. So this becomes w to the negative 6th power. Negative exponents we want to rewrite as positives. So this is 1 over w to the 6th power. So for our final answer, we're going to take 72 over 1 times 1 over w to the 6th, and we'll get 72 over w to the 6th. Okay, the last 4 problems we're going to do together in class the next time we see each other. So until then, folks, have a nice day. You're all wonderful people. Take care.